Finding it difficult to recollect the exact meaning of a notation while solving mathematical equations? Don't worry, Buzzle is here to help you out. Here's a list of mathematical symbols and their meaning, for your reference. Did you know? The first mathematical symbols to be used were ciphers. They were introduced even before the written language was introduced. Mathematics or math is considered to be the language of science, vital to understanding and explaining science behind natural occurrences and phenomena. It also happens to be one of the most dreaded subjects of most students the world over. Utter the word mathematics, and even grown-ups are known to shudder at the mere mention of it. We shall not delve into the reasons for this, but the variety of symbols used in equations also happen to add to the dread. Each branch of mathematics has its own special symbols that represent a particular concept. Thus, it is necessary for you to at least have a ready reference list of these conventions so that you don't mistake one for the other. We, at Buzzle, have put forth a consolidated list of all the symbols used in various branches of mathematics. So, the next time you try to solve any math problem, you will at least know what the notations stand for. Basic symbols, geometric symbols, algebra symbols, linear algebra symbols, probability and statistics symbols, combinatorics symbols, set theory symbols, logic symbols, calculus symbols, Greek symbols, basic symbols. Plus. It signifies addition of values. Minus. It symbolizes subtraction of values. Multiplication. It signifies multiplication of values. Division. It denotes division of values. Equals. It signifies two sides are equal. Not equal. It denotes two sides are unequal. Greater than. It shows one value is greater than the other. Less than. It implies one value is less than the other. Greater than or equal to. It symbolizes one value is greater than or equal to the other. Less than or equal to. It indicates one value is less than or equal to the other. Plus, minus / minus, plus. It denotes, the value can be both plus and minus. Modulo. It signifies finding the remainder of division of two numbers. Brackets. It indicates calculation of the equation inside it should be carried out first. Parentheses. It implies calculation of the equation inside it should be carried out first. Exponent. It signifies the number of times the number is used in multiplication. Square root. It symbolizes the value that can be multiplied by itself to give the original number. Cube root. It gives the value that can be multiplied by itself 3 times to give the original number. Fourth root. It is a value that can be multiplied by itself 4 times to give the original number. Nth root. Radical. It shows the value that can be multiplied by itself n times to give the original number. Percent. It signifies ratio expressed as a fraction of 100. Per mil. It symbolizes number of parts per thousand. Per million. It indicates number of parts per million. Per billion. It signifies number of parts per billion. Per trillion. It symbolizes number of parts per trillion. Back to top geometric symbols. Angle. It indicates the figure formed by two rays. Measured angle. It signifies the angle whose value is known. Spherical angle. It symbolizes the angle between two intersecting arcs of a sphere. Right angle. It indicates the angle that bisects the angle formed by two straight lines. Degree. It indicates the measurement of plane angle representing one full rotation. Arc minute. It gives the angular measurement equal to 1/60th of 1 degree. Arc second. It signifies the angular measurement equal to 1/60th of 1 arc minute. Line. It shows the straight line with negligible width and thickness. Line segment. It signifies the part of line with definite start and end points. Ray. It indicates the line with start point but no end point. Arc. It signifies the part of circumference of circle or a curve. Perpendicular. It symbolizes lines that are at right angles to each other. Parallel. It indicates the lines that are equidistant from each other. Congruent. It symbolizes the objects with similar geometric shape and size. Similarity. It signifies objects with similar shape but not similar size. Triangle. It indicates polygon with 3 vertices and 3 line segments as edges. Distance. It symbolizes the distance between the points x and y. Pi. It gives the ratio between circumference and diameter of a circle. Radians. It signifies the unit of angle measurement. Grads. It symbolizes the unit of plane angle measurement and is equal to 1/400th of 1 turn, 360 deg. Back to top algebra symbols. X variable. It signifies an unknown value. Equivalence. It indicates variables having same or identical value. It symbolizes equality by definition. It indicates variables that are equal by definition. Proportional. It signifies changes in variables that are always related to each other, using a constant. Weak approximation. It signifies variables that are weakly similar to each other. Approximation. It symbolizes variables that are approximately equal to each other. Lemniscate/infinity symbol. It indicates a variable without any limit. Factorial. It signifies the product of all integers less than or equal to n. Much less than. It symbolizes one variable is much less than the other. Much greater than. It indicates one variable is much greater than the other. Floor brackets. It refers rounding the variable value to lower integer. Ceiling brackets. It indicates rounding the variable value to higher integer. Absolute value. It gives a non-negative value of x, ignoring its sign. Function of. It defines one variable in relation to the other. Function composition. It combines functions such that output from function becomes input for the other function. Capital Pi. It gives product of all values in the specified range. Open interval. It symbolizes interval has no limits, that is, without any endpoints. Closed interval. It gives the interval with specified endpoints. Delta. It refers to change or difference in values. Discriminant. It gives the nature of roots for a quadratic equation. Sigma, summation. It refers to summation of all values in the specified range. Double summation. It signifies summation of values in 2 ranges. E constant/Euler's number. Its value is equal to 2.718281828. Euler-Mascheroni constant. The constant is equal to 0.52772156. Golden ratio constant. It indicates ratio of 2 variables should be equal to the ratio of their sum to the larger of the 2 variables. Back to top linear algebra symbols. Dot product, scalar. It signifies multiplying magnitudes of vectors and cosine of angle between them. Cross product, vector. It refers to multiplying magnitudes of vectors and sin of angle between them. Brackets. It indicates rectangular array of numbers arranged in rows and columns. Determinant. It gives the value associated with a square matrix. Norm. It assigns positive length, size, to each non-zero vector in space. Inverse matrix. It symbolizes the matrix whose multiplication with the original matrix is an identical matrix. Transpose. It refers to the matrix formed by replacing rows of the given matrix with columns and vice versa. Hermitian matrix. It signifies matrix with complex entries where the ith row and jth column is equal to complex conjugate of jth row and ith column. Matrix rank. It indicates the number of non-zero rows or columns in the reduced matrix. Dimension. It gives the number of rows and columns of the matrix, written as rows x columns. Back to top probability and statistics symbols. Probability function. It signifies the likeliness of the occurrence of the event. A probability density function. Integral of function of a continuous random variable gives the probability that the value of the variable lies in the given interval. Intersection. It denotes the probability of occurrence of events and B union. It denotes the probability of occurrence of events or B. Conditional probability function. It denotes the probability of occurrence of event A when event B has occurred. Cumulative distribution function. It denotes the probability that random variable x takes a values less than or equal to x. Population mean. It denotes the arithmetic mean of the population while considering each member of the population. Expectation value. It denotes the expected value of random variable x. Conditional expectation. It denotes the expected value of random variable x when the variable y is given. Variance. It expresses the spread of numbers of a given set. Standard deviation. It denotes the variation from the existing average value. Standard score. It indicates the number of standard deviations a variable is from the mean. Median. It denotes the middle value of random variable x covariance. It measures how much two random variables, x and y, change together. Correlation. It denotes the statistical relationship between two random variables, x and y mode. It signifies the most frequently occurring value in the given set. Midrange. It signifies the arithmetic mean between the maximum and minimum value of the set. Sample median. It denotes the average of all the values of a given set. Lower/first quartile. It denotes the 25th percentile of the given set data. Median/second quartile. It denotes the median of the given set. Upper/third quartile. It denotes the 75th percentile of the given set data. Sample mean. It signifies the average of the given set data, that is, the sum of the set data divided by number of entries in the set. Sample variance. It indicates the variance of the data set in the chosen sample size. Sample standard deviation. It indicates the standard deviation of the data set in the chosen sample size. Bernoulli distribution. It denotes the theoretical distribution of number of successes in a finite data set with constant probability of successes. Distribution of x. It indicates the distribution of random variable x. Normal Gaussian distribution. It indicates the probability of an observation falling between two real numbers. Uniform distribution. It indicates the probability that each value in the given data set has equal interval length in the given range from A to B. Exponential distribution. It signifies probability distribution which describes time between continuously occurring events at a constant average rate. Gamma distribution. It denotes the continuous two-parameter distribution from which chi-square and exponential distributions are derived. Chi-square distribution. It signifies the distribution of sum of squares of k-independent standard normal random variable. F distribution. It denotes probability distribution function, which is a ratio of two independent random variables, each of which has a chi-square distribution and is divided by number of degrees of freedom, k. Binomial distribution. It denotes the discrete probability distribution of the number of successes in n number of experiments, where each success is yielded by probability p. Poisson distribution. It indicates the probability of a given number occurring in a fixed time interval and/or space, if the events occur with a given average rate. Geometric distribution. It signifies the negative binomial distribution which is used to find out the number of failures before single success. Hypergeometric distribution. It is used to calculate random selection of a variable without repetition. Back to top combinatorics. Permutation. It signifies the possible arrangement of things in a particular order. Combination. It indicates the possible arrangement of things without any particular order. Back to top set theory. Set. It signifies the collection of distant elements. Intersection. It indicates objects that belong to both sets, A and B. Union. It refers to objects that belong to either set A or set B subset. It signifies few elements in the subset are similar to the elements in set. Proper subset. It indicates that subset A has fewer elements than the set B not subset. It signifies that A is not a subset of the set B. Superset. It symbolizes that set A has more or equal elements than set B proper superset. It indicates that set A has more elements than set B. Equality. It signifies that sets A and B have same elements. Complement. It represents objects that do not belong to set A. Relative complement. It refers to objects that belong to set A, but not to set B. Symmetric difference. It indicates objects that belong to both sets A and B but not to their intersection. Element of. It symbolizes that A is an element of set A, not element of. It indicates that X is not an element of set A. Ordered pair. It represents collection of elements of a set in a particular order. Cartesian product. It gives the product of two sets. Olive null. It indicates infinite cardinality, number of elements of a set of natural numbers set. Olive 1. It signifies cardinality, number of elements of a set of countable ordinal, well-ordered numbers set. Empty set. It refers to set having no elements. Universal set. It represents set having all possible values. Natural/whole numbers set. It refers to set of whole/natural numbers with zero. Integer numbers set. It indicates set of integer numbers. Real numbers set. It refers to set of real numbers. Complex numbers set. It represents set of complex numbers. Cardinality. It signifies the number of elements in set A. Back to top logic symbols. And. It signifies logical conjunction where two true operands can only produce a true value. Or. It signifies logical disjunction where two false operands produce a false value. Not. Negation. It indicates negation of the given value. Exclusive or XOR. It denotes exclusive disjunction where either of the operands should be true to return a true value. Implies. It indicates material implication where true value is returned only if either of the operand is true or false. Equivalent. It denotes material equivalence where true value is returned only when both operands are true or false. There exists. It indicates existential quantification where function of the operand is true only for one value of operand. There does not exist. It indicates existential quantification where function of the operand is true only for one value of operand. Therefore, it is placed before a logical sequence indicating conclusion of the required operation. Because/since. It is placed before a logical sequence indicating assumption or reason. For all. It signifies universal quantification where function of the operand is true for all values of the operand. Back to top calculus symbols. Limit. It denotes the value that function approaches when input approaches specified value. Epsilon. It represents a very small number nearing zero. Derivative. It indicates change in the function when the input values change. Second derivative. It returns a value which is the derivative of the given function. Nth derivative. It returns a value which is calculated by deriving the given function for n times. Time derivative. It indicates change in the function with respect to change in time. Partial derivative. It denotes the value that is obtained by calculating derivative with respect to one variable, while other variables are constant. Integral. It refers to antiderivative, and is the signed area of a region which is bounded by graph definite integral. Double integral. It denotes the integration of a function of two variables. Triple integral. It denotes the integration of a function of three variables. Closed contour/line integral. It denotes the integral of a function evaluated along a curve, that is, with respect to arc length. Imaginary unit. It indicates the square root of -1. Complex conjugate. It indicates the pair of complex numbers with same real part and imaginary part with equal magnitude but opposite signs. Nabla/del. It denotes the gradient and vector derivatives. Vector. It indicates quantity with magnitude and direction. Unit vector. It signifies a vector with magnitude 1. Convolution. It defines the integral of product of two functions when one function is reversed and shifted. Delta function. It is defined as the limit of a class of delta sequences. Laplace transform. It indicates the linear operator of function f which transforms f t to f's, with s being the complex argument Fourier transform. It signifies the transformation of signals into time and frequency domains, that is, breaks them into sines and cosines. Back to top Greek symbols. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, omega.